Hi, my name is Ariel, and this is my Physics in Media presentation. So we're going to be looking at a small clip from Pokemon Black and White, where Bianca pushes Ash into the water, and we're going to skip to 45 seconds in this video. So the video starts here.
I'm so sorry. Out of the way!
So that is the video. Oops. So we're going to be talking about the idea of conservation of momentum. And the definition of conservation momentum is that linear momentum, a vector p of a particle or an object that can be modeled as a particle or mass m moving with a velocity vector v, is defined to be the product of the mass and velocity of the particle, p equals mv. And the system is isolated and forces are internal in the system. So here is the before and after shot of the video. So here you can see in the before, Ash is at rest. He isn't moving, and so he doesn't have an initial velocity. And here Bianca is moving, so she has an initial velocity. And after the collision, Ash moves to the side and Bianca is still moving, so she has final velocity. We can define Bianca's direction as the y direction because she is just moving forward. So here we have the conservation momentum equation, where p initial equals p final, and here is the y direction, and here it is in the x direction. So this equation is in the y direction. So here we see that Ash and Bianca's initial momentum equals Ash and Bianca's final momentum. And as mentioned before, Ash is at rest. His initial velocity is 0. So therefore, he doesn't have initial momentum, which then our final equation is Bianca's initial momentum equals Ash and Bianca's final momentum. So the misconception here is that Ash gained momentum in the x direction. So here we see that Ash is moving to the side. So if we say that that is the x direction, it looks like he is gaining momentum in the x direction. But then, since Bianca has initial momentum in the y direction, Ash should have gained momentum in the y direction as well, which is also reflected here, as we can see in this equation. But then this doesn't really match the video because he is just moving towards the side. He's not moving backwards. And because Bianca doesn't have momentum in the x direction, Ash shouldn't have momentum in the x direction either. So Ash's momentum in the x direction, his final momentum should have been 0. But as we can see, his momentum in the x direction is not 0. And also after the collision, some of the momentum from Bianca, her initial momentum, should have been transferred to Ash. So which that allowed him to have momentum to move backwards. And as we can see here, he should have had some momentum, final momentum in the y direction. And then also Bianca's momentum, her final momentum should have decreased because of conservation of momentum. And therefore, what should have happened is that Ash should have moved, should have had momentum in the y direction, and Bianca's momentum should have decreased after the collision. So there are also other possibilities of what could have happened after the collision, and it also is very difficult to predict about it because it depends on the material and whether how hard or soft it is. So here we have some examples of what could happen after a collision. So we can see here a red ball and a gray ball. So you can see that the red ball has momentum. After the collision, the red ball doesn't have any final momentum, and the gray ball has gained momentum. And here we can see that the red ball and the gray ball has momentum. When they collide, they have momentum. They still have final momentum, but in opposite directions. And here we can see that red ball and the gray ball has momentum, except the momentum of the red ball is greater than the momentum of the gray ball. And when they collide, the red ball transferred momentum to the gray ball. So in turn, gray ball has more final momentum than the red ball now. In terms of the video, when Ash and Bianca collided, Ash should have exerted a force onto Bianca because of Newton's third law. And it is possible that the collision could have caused Bianca to have no momentum, while Ash gains momentum, which is modeled here. It could also be possible that when Bianca collides with Ash, depending on the angle, Ash would exert a force onto Bianca that would push her in the opposite direction Ash is being pushed in. But most importantly, we see that even through this example or this chart here, the direction of Ash should be opposite from Bianca's direction. And since Bianca has momentum in the y direction, Ash should gain momentum from Bianca in the y direction, and not in the x direction. So this is the end of the presentation, and thank you for watching.